We have been discussing so far in our course the application of Newton's laws and the relationships for kinematics as applied to mechanical situations. Galileo was instrumental in sort of coming up with a lot of these concepts, and as was Isaac Newton, of course, since they bear his name. And since that time, people began to investigate the question of, is there some other way of looking at motion? Galileo actually came fairly close to the answer to this question when he wondered if there was something that the pendulum, the mass of this pendulum, remembered such that it could come back to the same point every time in its motion. He also considered, for instance, a marble in a bowl, and it would roll down one side and back up the other and back up to where it started. So Galileo thought, is there something that this mass possesses that is conserved, that is the same? It must come back to the same place every time. Well, we now know what that is. We know that's called energy. And there are two types of mechanical energy that we deal with. Kinetic energy, which is energy of motion. Object which is moving, possesses mass, has kinetic energy. And as well, potential energy, an object which is experiencing a force on that object, but is not yet evident that that force has done any work. For instance, this mass pulled over here, we know that this mass possesses energy because if we let it go, it will begin to move, and it reflects, it manifests kinetic energy that can't have come from nowhere, so that energy must have existed as a result of this mass in the gravitational field. So that's potential energy. The word potential here is used in the context of not yet evident. There's different forms of potential energy: gravitational, electrostatic, magnetic, spring potential energy, and we'll deal with all of these as we begin to study the concept of energy and also the concept of work.